that it's not by chance. They haven't got some really freakish statistics that could occur just by chance. So if the probability that just by chance they're getting these freakish values for the detection of the Higgs particle, if that probability that it's just by chance is less than 5 sigma, 5 standard deviations, that is extremely unlikely. It's 1 in, I don't know how many, millions, billions, whatever. Okay, so you've probably heard of this term in the news. So now, if you haven't done any statistics, now you know what it is. Okay, now the variance, by definition, is just the square of the standard deviation. Okay? So it's just sigma, sigma or SD, standard deviation. So it's just sigma squared. Okay. So here's the formula. If you're squaring sigma, if you're squaring the standard deviation, this square root sign disappears, and you're left with what's inside, which is here. So in other words, it's the mean square deviation. Right? Now we can find a formula for the variance, the sigma squared, in a fairly convenient form. And here it is. So here's what sigma squared equals. So just square this out. So you get xi squared minus 2xi x bar, the average, plus x bar squared. All right? Now you can rewrite things. It's pretty easy. It's just fresher level. So it's not hard at all. So okay, rewrite this. You split it up into 3 sums. And some of this, some of that, some of that. So you got the sigma xi squared over n. Now that's just the average of the square of your scores. Right? The average of the square of your scores. Now x bar is just a number, so we can come outside the sigma. So then you get, or 2 sigma. So now you've got sigma xi over n. Well, sigma xi over n is just the average again. So we'll get x bar squared. And here just sigma x bar squared. Alright, so that's the average. So you've got 2x bar squared, 2x bar squared, and x bar squared is just a number, so it's a constant in a sense, and you're summing n of them. So you'll have n x bar squared over n. The n's cancel. Some of the mistakes I make. Right, so alright, so now you've got minus 2x bar squared plus x bar squared. So cancel one of them, so you're just left with this. And now you've got a formula for the variance, the standard deviation squared, in a fairly simple form. It's just the mean, in other words the average, the mean of the square minus the square of the mean. Okay, so the variance is the mean of the square minus the square of the mean. Right? Okay, so now we have a formula for the variance. And we will use the standard deviation, or sigma, in our analysis of the generalized uncertainty principle between 2 arbitrary, incompatible observables, A and B, with their corresponding operators, A hat and B hat. And we'll use the commutator of A hat and B hat to express that uncertainty, and the standard deviation, sigma. Okay? Alright, now we can translate this. Now this is just for ordinary statistics. X is just some real world score. I mean, talking about in the context of IQ scores. Right? Now, this is the variance now, right? It's the sigma squared, standard deviation squared. Now, the phenomenon of GMV, greater male variance, right, that's where the term comes in, GMV, males' IQ variance is about 10% larger than women's, and that number is very accurately known. because, as I was saying a bit earlier, every year in the US, hundreds of thousands of school kids have their IQs measured. So the variance ratio, in other words, the male IQ variance divided by the female IQ variance, is very accurately known. I mean, there's no doubt at all about that. This is a statistics that's extremely accurately known, and it's for certain. You can't question that. It's just hundreds of thousands of people, very large sample. In fact, it's virtually all kids in the whole country of a given age range who get their IQs measured. So it's not really a sample. It's just like everybody. And that variance is 1.1 every year. 1.1, 1.1, 1.1. And so there's no question of the fact that males have the greater variance. And that has consequences. That has political and social consequences. It means, for example, the feminists who are complaining about the fact that society is a patriarchy, in other words, dominated by males, that's not going to change. That's a biological consequence of GMV. If the genii are males, it's the genii who create and drive society. They dominate society because they're genii, and they're males, and that's not going to change. So the feminists are just going to have to lump it, meaning accept it and live with it, right? Because it's a biological consequence. You may ask quickly, just a little aside here, you may ask quickly, why is that? Best theory I've seen is, now if you don't know any biology, you probably won't understand what I'm saying, but I don't want to go on a tangent too long, but it's thought to be a consequence of the fact that men have only one X chromosome, the sex chromosome, and women have two. Now, there are about 25,000 genes in the human genome, and we have 23 chromosomes each, or pairs, one pair from the father, one from the mother. And so that's roughly about 1,000 genes per chromosome. That's a lot of genes. Now, the Y chromosome for males is extremely small. Only a handful of genes on it. So that means for males, with just one X chromosome, it has about 1,000 of those chromosomes that are not paired off with another X chromosome, which is the case for females. And it's just a fact of life, consequence of evolutionary theory, that there are far more recessive genes than dominant genes. Now, when a recessive, if you have a gene that's paired off male and female, or rather parental, mother and father, the dominant gene will switch off the recessive gene, and it'll only be the dominant gene that gets expressed. Now, in males with the X chromosome, their one X chromosome, all those recessive genes on that X chromosome do not get switched off, because there's no other X chromosome with a dominant gene to switch it off. Okay? And since there are far more recessive genes than dominant genes, it's not surprising over a whole population, millions of people, males will just be more varied, more variable. Right? They'll just have their scores more spread out. So more morons and more genii and more complete slackers, lazy people at one extreme, and extremely motivated, pushy, ambitious people at the other end. So it's not surprising that men just dominate. They're pushier, the consequence of GMV on pushiness, and IQ and so on. So the patriarchy is with us for life, because it's just genetically determined to a large extent. And I get impatient with the ignorance, the iscianacy of feminists who just don't know about this stuff. Anyway, all right. Okay, so variance is the mean of the square minus the square of the mean. We have this useful, easy formula for the variance. Now let's translate this into quantum mechanics. Okay? Now we're defining the uncertainty in the measurement of observable A. We're defining that uncertainty as the standard deviation, as sigma. Right? So for delta A, we could just call it sigma, you know, the sigma of A, the observable A. And so we'll define this as, you know, the mean of the square minus the square of the mean. Now, the mean in quantum mechanics usually gets called the, what's the word? Expectation value, right? So you're squaring the expectation value, and this is taking